This lecture covers software effort estimation. The largest expenditure for a software development project is for the salaries of the development staff. Effort estimation involves approximating the level of effort needed for a project in terms of person weeks, person months, or hours. When person months are used, the average monthly salary of a software engineer multiplied by the estimated person months is the dollar amount the project costs. If 10 person months are estimated and the project timeline spans 5 months, then the estimate would cover 2 full-time development staff members. Effort estimation is needed for project managers to plan and schedule project activities. The effort estimation approaches discussed in this lecture are function point, COCOMO 2, Delphi estimation, and Agile estimation. Function point analysis is a method of breaking systems into smaller components that are easily recognized and evaluated. A function point is a software unit of measurement. Advantages of the function point method are estimation can occur early in the life cycle, non-technical persons can apply the method, and it is independent of the programming language. Disadvantages are it is considered subjective, and for some projects, the category counts are not easy to gather early in development stages. System functions are separated into 5 categories: user inputs, user outputs, user queries, files and database tables, and external interfaces. The counts of these categorized functions are recorded. A complexity is assigned to each count, and a gross function point GFP is computed, which is the sum of the 5 counts multiplied by the complexities. For instance, if the number of external interfaces is 4, the number of files and tables is 30, the number of user queries is 8, the number of user outputs is 5, and the number of user inputs is 10. And all complexities are simple. Then the counts times the complexities are 30, 20, 24, 210, and 20, respectively, and the gross function point is 304. Then 14 processing complexities are determined by ranking the influence of the 14 characteristics from 0 to 5. A characteristic rated 0 has no influence on the system. A ranking of 5 is essential to the system. This is done by answering the 14 questions shown and concluding the effect of the process on the system through process complexity rankings of 0 to 5. The processing complexity adjustment is computed by using the processing complexities. The formula is 0.65 plus 0.01 times the sum of the 14 processing complexities. Then the function point FP can be calculated, which is the gross function point times the processing complexity adjustment PCA. If PCA is 46 and function point is 13,984 function points, and the productivity of one developer is 60 function points per week, then the effort is the function points divided by the productivity, which is 233 person weeks. If the team size is 5, then the project duration is the effort divided by team size, which equals 233 person weeks divided by 5 persons, having a duration of 46.5 weeks. Constructive cost model COCOMO is a procedural model for estimating effort, cost, and schedule. Kokomo was developed by Barry Beam in the late 1970s and published in 1981 in Dr. Beam's book Software Engineering Economics. Kokomo 2, developed in the mid-1990s and published in 2000, is an update to Kokomo 81. Kokomo 2 takes modern coding practices into consideration: code reuse, desktop programming, and commercial off-the-shelf software. Kokomo 2 consists of 3 models. The application composition model is used for building prototypes in the early stage of the lifecycle. The early design model is used during the early stage of a project. The post-architecture model is used after the software architecture has been defined. Kokomo 2 is a comprehensive system that is detailed in the textbook. The Delphi estimation method involves forming a group of experts or experienced developers. The system and its major components are described to the group. Each expert independently estimates the effort. Each expert presents the estimate and rationale behind the estimate. The last 2 steps are repeated until a consensus estimate is reached. Agile estimates are expected to change as reality changes. The estimate takes into account the current knowledge and uses intuition and common sense. Planning poker is a modified Delphi approach. The following steps demonstrate an agile approach to effort estimation called planning poker. Each participant is given a deck of cards containing the Fibonacci sequence numbers or any agreed upon numbers and reminded that good enough is good enough. The moderator reads a description of the story point and the product owner answers questions. The participants perform the following. Each participant selects a card representing their estimate, and participants show their estimates simultaneously. Participants with the highest and lowest estimates are asked to explain the rationale. Participants repeat the last 2 steps until a consensus estimate is obtained.